What's up, guys? Welcome back to Vanover Machine and Repair, and welcome back to another interesting video. Now, if you're anything like me, I love my forklift, and my forklift is in really sad shape. It's been needing to be replaced for years, and I've been kicking the can down the road until today. Now, what better to replace this old, worn-out forklift with another broken forklift? But before we get into what we bought with this forklift, let's take some time and chat about the unit we're going to be replacing, because I know you guys are interested to hear a little bit more about that. This is our beloved Alice Chalmers PS500 forklift. Now, I'm going to be honest, I have a love-hate relationship with this guy. This guy has done tons of work in our shop, and it was gifted to me for free as long as I fixed it, which we did the first week that I moved into the shop, and it has been nothing but joy and hate the whole way. The main issue with this forklift after we put a bunch of work into it in the beginning is it does not have brakes. It also has a short mast height and no side shift. So between those three things, when it comes to lifting loads, it can be pretty sketchy, not only because we don't have side shift, we can't go any higher than 9 feet, but also with no brakes, it really takes a feathering of the clutch to make sure that we can come to a stop. And ultimately, I have been kicking this can down the road and milking this for as long as possible. But recently, it became obvious that I needed to move on. So a couple months ago, or I believe it's 2 months ago at this point, this died on me in the middle of a job. And what we figured out it was the starter went bad, basically, and the starter we couldn't get. And simultaneously, the ignition switch went bad, which we also couldn't get. So I was able to rebuild the starter and acquire a solenoid off of a different unit and keep it going. And I actually bypassed the starter with a nice Allen Bradley push switch. So it is currently working, but it's very rare when your wife tells you, hey, you need to replace that machine. And so between that and working on the Lucas and needing to remove the knee, which is over 6,000 pounds, it was time to look for a bigger, newer forklift. So I'll give you a quick walk around to kind of show you what we have here, but you've seen it in the videos. It's old, it does work, and yeah, that's pretty much it. And then we'll jump right over to the new forklift purchase. Jumping on board to this beauty, we got a brake pedal that does nothing. We got an ignition switch that does nothing. This water gauge works. This hour meter says 6,000. I'm sure it's rolled back 1 or 2 times. Oil pressure doesn't work. The amp gauge works. And yeah, pretty simple. So let's start this thing up and show you what it's like. Well, that's pretty much it. That's just kind of a sample of getting it going. You could see it had a little bit of a longer crank there, but ultimately that's pretty fast. Generally on the first start, it can take 20 to 30 seconds, and sometimes the battery gets pretty unhappy with that, but it pretty much always cranks. I'm under the impression that it has low compression. Once it gets going, it runs pretty decent, but talking to the reps over at the Komatsu dealer, they think that this has low compression, and it was a pretty common failure on these engines, not really worth putting the time or money into. So that's kind of a sampling of that. Ultimately, we use this forklift a ton when we were doing a bunch of moving in the shop, which you guys have already seen. And during that time, the steering got real stiff, hydraulics were acting wonky, and it kind of acted like it was low on fluid, and it wasn't. So there was probably some clog intermittent in the system, because right now everything works fine. But yeah, we put this thing through a lot of work. We probably have over 100 hours on it in the last 3 months, which is a lot for us, and it has done a good job. But it is time to be laid to rest. So with that being said, let's jump over to what we went with next and why we went that direction with the Hyster. Let's talk about our Hyster 60EZ. Now, this is an interesting one because I really wanted a Toyota forklift. And I've been looking for about 3 months. I've gone to the Toyota dealer, I've gone to independent dealers, I went on Marketplace, and I bid and lost on several Toyota units on BidSpotter, and it never seemed to line up. And we found this late one night on Marketplace, and the next day I went and looked at it and picked it right up. And the only reason that we went with this unit was the cost, and because the style of forklift is a little bit unique and a little bit hard to find. So when I started my forklift search, I concluded that what I really wanted was a pneumatic tire Toyota 6,000 or 7,000 pound forklift. They're really nice, really expensive, but the main con is that those pneumatic tire forklifts and those 6 and 7K models, they're a lot bigger because of the stability, and our shop is kind of small. We need that nice tight maneuverability. And so after looking for many months, what I realized was that Toyota actually makes a BCS model, which is called a box car special. Basically, that's everything that I wanted in a forklift. It's a high weight capacity and a short body. So basically, they stack the counterweights in the back, and they allow you to get a nice compact forklift that can actually lift quite a bit of weight. We do have several things in my shop that are 6,000, 7,000 pounds, and I'd love to be able to pick those up in one shot. But ultimately, when you go from a 5K to a 6 or 7K, the amount of forklifts on the market goes down, and the BCS style, which is the short style, also makes things quite rare. So if you're looking for a 6,000 or 7,000 pound BCS forklift, there's really not a lot of options. That's probably only 5 or 10% of the market. So when this guy popped up, it was not a Toyota, but it looked relatively clean, and the price was very low. And we may have a large material purchase coming up, and I thought to myself, maybe I would compromise on the forklift, save a little bit of money for that next purchase, and it meets all the criteria except it's broken and except it ain't a Toyota. So we went ahead, took a look at it, and I ended up coming home with it. So let's talk a little bit more about some of the issues with this forklift and what we paid for it. $3,000, that's what we paid for this nice little Hyster. And I think that's a relatively good deal, except for the fact that I know that it needs a battery. And when I went into purchasing it, the gentleman was asking $4,500. We got him down to $3,000 because it had no charger and the battery would only hold a charge for 15 minutes. And I think even if we have to replace the battery, by the time we replace the battery, we're going to be around $7,000. And for the lifting capacity and the short wheelbase and the fact that this forklift seems to be in relatively decent shape, I think that's still putting us in a fairly good position. But before we commit to changing the battery, I want to do everything in my power to see if we can bring this battery back to life, or at least increase the time that it will hold a charge, because there's several tricks and techniques you can do to have success in that area. So with that being said, let's open up the seat, let's take a look at the battery and figure out the condition of the unit we just purchased. Here is a close-up of our 48-volt Hawker forklift battery. Now, most forklift batteries are 36-volt. There are some 24 and some 48. It's not super uncommon, but the 48-volt models are typically on the larger units. Now, when I bought this unit, I did not open this lid, which I should have, but you guys know how that goes sometimes. You get stuck in your mind, you check certain things, you forget others. The gentleman selling this told me that the battery was only lasting 15 minutes. They called a technician out. They added some fluid to the batteries. It didn't really improve. They told him he needed a new battery, and so they just didn't want to mess with it. They posted it up for sale. It's been up for sale for 4 months, and of course it's junk. No one wants it. So when I got this back to the shop, the first thing I wanted to do was open the lid and start checking the voltage on each of the cells just to see the condition of the battery and see how many bad cells we had. And when I opened this up, I immediately realized we have a major problem here. So this is a 48 volt battery, and 48 volts is broken into 2-volt cells. So that means we have 24 batteries here, and they're all connected in series to jump up the voltage. And the way they have this wired currently, they actually only have it wired up as a 36 volt unit. That threw me off for a little bit. I thought maybe the unit may have been a 36 volt, but after some confirmation, I realized that what they did is they just bypassed the entire back row here, most likely because there was an issue with some of these cells, and they were running it on 36 volts. Clearly, that didn't work. So that's my guess is what the technician did when he came out, was he identified some bad cells, said, hey, I'll try to jump them, we'll see what happens. They tried it didn't work out, and they parked it. So that kind of put me in a little bit of a precarious situation because this battery is improperly wired. And you could tell that people have been monkeying around back here. Some of these plate covers are burned. It just looks, a little bit rough. This solder job here, and I can give you a close-up, is pretty rough. And they actually cut off the terminals on both sides here, making it a little bit more difficult to bring it back to factory. So what we did was, the benefit of it being kind of wired improperly here is this last row is isolated. And so we tested all of the cells. Everything from here forward seems completely fine. It was about 2 volts per cell. And a couple of these were 2 volts per cell, but we identified 2 units that were like 1.7, 1.6. They seemed a little low. And they also simultaneously have an X on each cell. So I'm guessing the previous technician also noticed that and marked them. And so basically we were able to charge up all of these cells back here as 6 units on a 12 volt charger. So with that being said, we're going to come in here and we're going to see if we can put all this back to normal, and then we're going to see if we can add some acid and distilled water to these cells and charge it up and see if we have any luck reviving this unit. Now from the get-go, I'm going to tell you very honestly, I have 0 experience working on these batteries. This isn't going to be a how-to video. This is going to be what I do. Maybe it'll work. Maybe it won't. Take it as a case study, and maybe you'll learn something from it. The proper process here would be to recondition these batteries by removing the entire box, pulling each cell out, desoldering all these connections, replacing the bad cells, applying a desulfication process to all of the units, charging the unit, discharging it, recharging it, clean all the corrosion off, put a new sticker on it, and Bob's your uncle, you have a reconditioned battery. What we're going to do is do a kind of quicker method, so that way if it works, great, and if it doesn't, we don't have too much time into it and we can go directly to replacing the battery. I don't want to dump 20, 30 hours into reconditioning this and then realize, guess what, it didn't work and I still have to buy a battery. So the game plan here is we have our ghetto solder job there. Off camera, I went ahead and charged up all of these cells in the back. They were low on voltage because they have been disconnected. So these cells are currently up at 2 volts or around 2 volts. All of these cells are around 2 volts each, so that's great. The next step is we're going to go ahead and fix these terminal posts that have been damaged. We're going to pour some new lead. We're going to move this to where it should be, and then we're going to go ahead and fix the mechanical issues with the battery and the connections. We're going to add some acid, we're going to add some distilled water, we're going to charge it up, and we're going to go from there and see how it works. So let's jump into getting these battery connections buttoned up a little bit more official. I'm going to start with a 22 millimeter or 7/8 drill, and we're going to come in here and drill down, and that should free up these terminal posts. Then we'll move our pilot drill. Okay, that was a bad solder job. Didn't even reach to the posts. All right, so we'll clean this up. All right, we got this drilled out and we're going to go ahead and get this installed up here on the battery on this proper negative position here. So what we're going to do is, previously what they did is they did something very similar and they poured lead in here and it gripped on. It works fine, but we're going to clean this up just a little bit more. We're going to use flux, and we're also going to clean these up and drill and tap for a bolt, a stainless bolt to be precise. Hopefully that'll minimize corrosion, and hopefully that'll give something for the lead to kind of pool around to give it a little bit more strength so that it won't kind of pull off from just making a friction connection here with the other lead. So we got a 5/16 stainless bolts here that have a nice chamfer, so that'll help keep them from kind of pulling back. Got a 7/64 drill bit. I don't know how deep this goes. Do the same thing over here. We went ahead and added some flux over at the battery posts. We have some lead that we removed, and we have one of these crucibles. So we're going to heat this guy up. I think we probably have too much lead in here, but that's fine. All right, I think this is a solid pour. This seems nice and tight. So we're gonna leave this. So we went ahead and ground this. We're gonna move over to the other side. Start by just wire brushing these and cleaning these up. All right, now for this side, we need to replicate this bar here. So we gotta tie all four of these together with this piece of lead here, which we do not have. And I wasn't able to source one of these. It's the weekend. We're trying to get some results here. So we're gonna make a bar out of aluminum. Aluminum is not as good of a conductor as copper, but it's right underneath. It should work fine. So we're just gonna off camera cut out a piece of flat bar, drill some holes in it, set it down, and then over the top we will pour some lead. And I think that will work as far as a conductivity of what we need. So that's what we're gonna do. All right, next step is to go ahead and tie all four of these posts together. On the other side, we have this nice bar here. I wasn't able to get a hold of one of these bars quickly, and it is the weekend, so we're gonna do a makeshift option that I think will work. We're gonna take a piece of aluminum. Aluminum is a pretty decent conductor. We're gonna drill 4 holes based on this distance. We'll set it on, and then we will pour some lead over the top of those, and that should make a good connection. All right, a little bit of a change of plan. We cut out this aluminum bar. We're gonna put 4 holes in it so we could push it down over there and do some lead on the top. but I realized that that's probably not going to make that great of a connection. So instead, we went to the auto parts store. This is not the right way to do it. It's probably no better or worse than this, but we're actually going to put these, basically pound them on here, and then we can tighten them, and then I'm going to backfill the holes because they're a little short with lead. So that should make a good connection, and the benefit of doing it this way is we can connect these over to these other ones here with the studs, and if we want to disconnect this pack or isolate a couple of the cells for diagnosis, we can do that pretty easy. And I think this will give us a much stronger connection than what we were doing there, since we have a mechanical connection in conjunction with a lead pour. So we'll get these pushed down, we'll tighten them up. We're going to drill holes and tap them for some smaller bolts, and then we'll pour all of these and then get them tied in. For the lead, I bought some of these at the auto parts store. These are screw-in terminal posts. So we'll melt these down, and that'll give us the material we need to pour into these holes. We used the oven on the last 4, and this turned out a lot better. All right, we got these all cleaned up. We have a bar here to join these. All right, that's it. Well, we found another problem. This was underneath some duct tape. It looks pretty bad. This is cut. I'm gonna go ahead and fix this off camera just by splicing in a new butt connector for this heavy gauge wire, and we'll get this properly, probably heat shrinked. But yeah, this is also gonna cause a problem for battery draw and might be a contributor to our battery issues. Oh, that is some thick wire. All right, we got this guy repaired. I ended up just cutting out extra length and redoing both ends, so we resoldered those. And then I just used some tape so that this is actually shorter, which will have less chance of getting pinched. And we removed that section that is bad, so that's good. So that's done. I think all of our connections are done. We can move on to the acid/distilled water. And then after that, we can move on to charging. All right, we're ready to move on to the fun part, the dangerous part, so to speak. We have the acid, we have the distilled water, and we have the hygrometer, or whatever they call this thing. Picked up one of these on Amazon, super cheap. So the process here is relatively simple. We remove all the water caps. We take the sucker, we suck up the fluid that's in the battery, and we look at the levels. And if it's in the green, it's gonna be fine. If it's yet white, you know, red, bad, all that kind of stuff. So again, I'm not an expert on this. I've watched a couple videos, and we're doing a trial by fire. Now we have distilled water and we have battery acid, which I was able to get at my local parts store. And the way that this works is we are not doing a desolidification process. We're just trying to bring the levels back to factory so we can see if we can get a charge. During the desulfication process, what you're doing is you're adding a special chemical. You're hoping that the corrosion on the plates sort of shakes loose and falls to the bottom, and then the plates can hold more energy. At least that's my understanding. So what we're trying to do here is just bring the levels back to where they need to be, because right now with the fluid levels below the plates, it's not going to operate properly. Now the question is, which one of these do we use? And the answer is, I don't exactly know. Ideally, based on my understanding, the water neutralizes or kind of waters down the acid, and the acid is more concentrated. And you want a proper ratio or a range where it's not too acidic or it's not too watery. Now the problem we have in this case is the water is below all of the levels on all of these batteries. So ideally what I would do is I'd come in here and I'd squeeze some fluid in here and we'd check. And if we needed it more acidic, we add more acid. If the level was fine but low, we'd add more water. But in this case, it's so low that we can't even measure it. So what I'm gonna do is I'm gonna start out by adding more water to all of these. This is distilled water. And then once that's done, I'm gonna add acid as needed once I can check the levels. Now I know when we add the water, it may sit on top, so it may not mix properly and give us a false low acidity reading or whatever. And then that it just is what it is. So hopefully this is just better case than where we started. When handling the acid, we're gonna wear gloves, I'm gonna wear a mask, and we don't wanna splash this on our skin. But the water, pretty straightforward. So we'll start over here. I'll get out of light so I can see in there, and we'll start adding some water. Actually, what I think I'm gonna do is I think I'm gonna add water everywhere, then we're gonna try to charge it. After we charge it, hopefully that kind of moves everything around, and then we'll measure the level and add the acid where needed. So let me go and add a bunch of water. All right, we got everything filled up. I made some little caps over here, and for this one, we're just gonna use a rag for now, so we don't have any shorts. I think there's actually extra clearance in the back, so I think we're good. So we'll set this guy down and we'll give it a charge. We were getting 37 volts before, so hopefully we're getting closer to 48 now. Ooh, that looks good. I think our forklift's gonna be happy. Not sure how long the battery's gonna last, but I think the unit should be happy. So we'll get it started up, moved into position. I gotta finish installing my charger, and we'll get a charge on this bad boy. All right, so we plugged in the battery, and now we're getting an error, battery voltage too high. Now, I could be wrong, but I was doing some research, and if I remember right, I watched a video where they talked about you can adjust the battery voltage. So my guess is that whoever did this rig job on the battery programmed it to 36 volts. Don't know if that's true, but I know based on the video I watched, you can actually change the battery voltage. So if it thinks it's 36 and we're giving it 48, it's not going to be happy. So let me watch that video again, see if I can make an adjustment here, and go from there. All right, it's never easy as it seems. So I did look up the video, and guess what? It is that easy. You can reprogram the voltage. I think that's what happened, but we have an issue. In order to get into the menu, we need to put a passcode in. Hyster, in general, uses the passcode 5555. Sometimes people change it, but it comes from the factory with that passcode. The problem is this 5 button on our computer board doesn't work. So even if it did work, there's a 50% chance that we'd be able to get into the menu and change the voltage. And if we try to fix this, it's possible that someone changed the code and we just don't know what the code is. So this might be a dead end, but either way, we're gonna need this button to work so that way we can navigate the menus. So the next step here is to take this apart and try to get this board out behind here and see if we can do a repair or a modification to get this 555 button working. Maybe a little hard to see, but I'll put the key on. All right, so key's on. It says battery voltage too high, call technician. All right, we hit the star key, enter password. See, the 1 works, the 2 works, 3 works, 4 works, 5 does not work, not at all. And that's the number we probably need to work, maybe. So that's the issue we have. Let's see if we can fix it. Unfortunately, it looks like someone's been in here before because the screws holding this dash on are finger tight. There's one. And I don't even see a screw over here. So that's not a good sign. There are some screws at the front that have been painted over that might be holding on to this. How fun is it working on junk? Junk that people messed with. People never fix it right though, so come in behind them. You always have an opportunity to make an improvement. All right, see if that had an effect. Yep, that was it, okay. Let me get a light, maybe I'm missing something. It looks loose. Oh, you know what? I bet it's the connector. See the board. Let's take this guy off. Interesting, yeah, that doesn't look great, whatever that is. How much you want to bet there's a screw holding this on right here? Yep, right there. Was doing a good job too. All right, now we pull this out. Oh, nope. There's a bunch of screws. Broken, okay. There she goes. Okay, we got a proprietary connector. That was not too bad. Look at that, we got it out. All right, we're gonna get it over on the bench and take a look at the board. All right, we got the board out and here's a look at it. And over here in this corner, we've identified where the buttons come into. So it's gonna be kind of hard to see, but I'm gonna plug this back into the forklift and I'm gonna short the ground off of each one of these, which should be an individual button press. And we'll see if we can get our 5th button press and if we can get into our menu. It's gonna be a little bit difficult to show, so I'm gonna do that off camera, and then if we can get into the menu, I'll bring you along for that. Well guys, we've been defeated. You could probably hear the disappointment in my voice. So we were able to take the circuit board out and we took it apart, and I called my friend Stefano. He walked me through the process of taking a jumper, and we were able to take out the ribbon strip that controls the LCD and identify which number was number 5, which is that broken button. And we were able to actually jump. I had someone, a helper, look at the face while I was on the back of the board and jumping basically the ground to the number 5 spot, bypassing the screen where we have that issue with that tactile button, and 55555 will not get us into this computer. I sat here for probably an hour helplessly trying different combinations, but there's probably about 100,000 possible combinations with 5 digits and 5 letters / numbers. So I'm not gonna sit here and guess all day. Unfortunately, what I need to do is call a Hyster rep to come out and program that. The other option would be to buy the scan tool for this piece of equipment, and it's rather pricey. and there's no guarantees that I would get the license to come in here and to make the tweaks. So barring basically trying a bunch of combinations, I'm going to be paying someone probably $500 to $1,000 to come out here, punch in a code, just so we can switch this from 36 volt into 48 volt. And at that point, we can test to see if our battery works. And if it does, happy days. It's all worth it. If it doesn't, then we're going to be replacing the battery, replacing potentially the screen so we can get a working number 5 button, and paying to have someone come out here. Only after all of that can we assess the rest of the machine for any damage. Again, visually everything looks fine, but I've only driven it, 2 miles an hour on and off the tow truck, so we haven't really even given it a full shakedown. So a little bit discouraged. We're going to try to drag this with our old forklift, which I think is ironic because that's supposed to be the unreliable one. We're going to drag it into the corner and see if I can at least get it to charge while we're waiting, because I did get the charger hooked up. Yeah, that's what no brakes does. That's why we need a new one. Come on back, girl. Come on back. Oh, she's heavy. Nope, she don't like it. Here we go. All right. Yeah, I know these are the wrong straps. I wanted to see what they could take. Smoky. Let's start you up. Maybe you got a parking brake. Heck yeah. A few weeks have gone by and we have some major updates on the Hyster in regards to the battery. Now, when we last left off, we were having an issue because we fixed the battery, restoring it back to 48 volts, and it was having a hard time communicating with the computer because the previous owner set it to 36 volts. We did a bunch of back and forth and figured out that the code was not 5555. I actually used Stefano's help. We went into the chip, the circuit board, we hot wired in a new button, and we were able to get the 5 key to work, but that still didn't help us. The only step from there was to have someone come out and reprogram the computer, and that's what we had to do. And I didn't film that because filming someone else work, especially Hyster employee, probably wasn't the best thing. But the unit is reprogrammed. They also reprogrammed the code, so now that I have it, I can go in there and make the adjustments. And with that set up, we were back to a battery that could communicate with the actual computer. Now, from there, I went ahead and added some battery acid and some distilled water to the batteries, And I didn't show that because I wasn't following a proper procedure, but we used about 9 gallons of distilled water, and I added, I don't know, maybe 2.5 quarts of acid as well, and then we kind of checked it with the hygrometer and just sort of adjusted the levels. So up to this point, I was still struggling with getting a full charge out of the battery or any charge. I could drive it around for about 5 or 10 minutes and it would die. And when you hit full throttle, it would air out because the issue is not voltage, it's the actual resistance of the battery and the amp draw, and there wasn't enough available amperage from the battery because the battery is 20 years old and is in rough shape, and it just keeps dying. So I have had this on the smart charger that we have here, which is a really nice unit, multiple times, and I think eventually we're to a point now where it might be holding a charge just a little bit longer. Yesterday, the battery capacity was only 3 bars out of like 15, and this morning when I came in, we had a huge smell of hydrogen in this area, and the battery capacity is now reading probably like 12 bars. So I don't want to get too excited yet. This process of sort of bringing the battery back is very slow and uncertain, but it looks like it may finally be very promising. So with that, we're going to move this other forklift out of the way. I'll show you what's going on with the display, and then we're going to get in this bad boy and take a drive. Well, that started up right away. All right, we're gonna get into this bad boy and see how she looks. We're gonna turn the key on. So before we were getting an error code here, which was an error code 7 for a throttle position switch. I was able to figure that out with the technician, and we got that addressed. And as you can see, we have maybe 5/8 of the way across battery, which is great. Before it was over here in the red only. So I'm not going to be overzealous and think that this battery is going to be fully saved. But hey, if we could get an hour out of it maybe, then I could prolong buying a $5,000 or $6,000 battery. So we're going to take this for a rip down the road. I'm going to put the GoPro on and we'll see how she does. All right, here we go. It's been about another week, and just wanted to give you an update on the battery. We're making slow progress, and with these batteries, slow progress is good. It's a lot better to condition the battery over time as opposed to try to jump start it real quick. So at this point, I would say the battery has leveled off, meaning that it's not improving anymore. Currently, when we plug it in, it does charge, and the charger is happy with the battery, but as you can see, we're basically getting 237 amp hours of charge out of the battery. Now this is a smart charger, and sometimes that works for us, sometimes it works against us. In this case, it thinks that's the capacity of the battery, or that's what it thinks the battery has, and the battery should be 850. So my math's a little hairy, but it's probably about 1/3 capacity according to the charger. Now that's not accurate at all. The forklift can run for about an hour, which seems good. That was my initial goal, but the problem is the amp draw. And if I use the forklift for moving pallets around, doing general stuff, I can probably drive it for an hour, even unloading trucks. And that's mostly what you do with a forklift. So from that standpoint, it's a win. When we take this and unplug it, we'll see full voltage on the charger, and we should be able to do pretty much any normal task. But you know how I roll around here, and I'm not normal, and we do heavy stuff. So I went to lift the knee on the saddle, and this did lift it on a full charge, but after the 3rd or 4th lift, the battery aired out. And the reason for that is amp draw. The battery has voltage, the cells measure good, but there's just too much sulfating on the batteries, and or the batteries just don't have the correct internal resistance, and so far the amp draw just isn't there. So we're going to do something that seems a little bit extreme, but honestly it's not really. We're going to hook a welder up to the battery. I'm going to park this outside, and we're going to see if we can boil the battery to break up some of the sulfates, to see if we can get some additional amp hours out of the charger on its perspective, but more importantly to see if we can get more grunt or actual amp draw from the battery. Right now on a full charge as a control, I can lift the knee or the saddle up and down about 6-7 times, and then the battery airs out and goes into limp mode. So for me, that's a control. I can lift it about 4 or 5 feet off the ground. Maybe I could go higher. I just didn't want to go too crazy. So if I can get 10 to 12 lifts out of that, that will tell me from a pragmatic standpoint that we're making headway on the battery. I also ordered up some connectors, so you can't see it, it's probably out of the shot, but there was some quick and dirty connections that we made on that side, and I'm going to go and address that. If all this doesn't work, we're going to move on to the next step, which is trying to recondition the battery ourselves, and we'll make a separate video on it. But at this point, we're just trying to do some quicker, lower time investment options to see where we're at. So with all that being said, we're going to get this pulled outside where it's nice and safe and there's good fume exhaustion, and we'll get up the welder set up and we'll go from there. All right, we're ready to go. We got the forklift outside. We got our HTP 221 AC/DC welder. We're going to set it up in the stick welding setting, and we're going to give this a whirl. Things go bad, the unit's outside, it can catch fire, we'll close the door, call it good. But the charger will put out over 130 amps, so I think we're going to be fine. It's basically like we're charging the battery at a high current. So the most important thing to do when we're watching this is to monitor the battery temperature. We don't want to overheat it too much. And yeah, we'll give this a whirl. I'm going to leave this plugged in, we'll start up the welder. All right, so currently it's in the stick mode. I'm going to turn it off. We're going to plug the lead back in and fire it up. All right, we just blew up our $2,000 welder. All right, fun. Well, as you may or may not have guessed, our quick and dirty methods for recovering the battery were not successful. Now, technically, we did have some success compared to where we started, but ultimately, sometimes when something is in such bad shape, you need to take it to the next level. So we ended up actually rebuilding the battery in this forklift, and we decided to make a separate video on that, which will be coming out right after this. So now the battery is basically reconditioned by me and is able to provide the level of service that we wanted. But I did want to keep all of this footage in the beginning of this video of us trying these more simple methods so that you could see which was effective and which wasn't. And overall, I think like anything, putting attention to something is more effective than neglecting it. And so even though we weren't able to be 100% successful with the quick fixes, we did make an improvement. When we got the forklift, it would barely run and operate, and even after doing some of the quicker fixes, we were able to drive it around for 10 to 20 minutes. The real problem came in was with the amp draw. And even though we could drive it for 20 or 30 minutes, and before we couldn't really do that, anytime we went to pick up a heavy load, the forklift aired out, and that's just as a result of too many bad cells. And so we did get the cells replaced, and we'll review that in another video, and we are at the point where we can now lift heavy objects all day long without the forklift battery airing out. So we went ahead and lifted the saddle on the Lucas, and we were able to lift that about 20 times, and the battery went down like 2 bars. So overall, I'm very happy with that. That is a huge win. We don't use the forklift often. We probably use it 4 or 5 times a week, maybe 15 minutes at a time. And then there are certain days where we'll use it for maybe an hour at a time. So having a good charger and a decent battery, not a great battery, but not a bad battery, but a decent battery like we have, will allow us to do what we need to do without dropping $6,000 on a rebuilt battery or $10,000 on a brand new battery. So overall, I am really happy with how things turned out, even though we went a little bit further than we did. And overall, as a unit, the forklift is in really good shape now that we've made those fixes that we discussed. What is next on the docket for this, and we won't be filming this, as we do want to source a side shift for this unit. So if you know of one, let us know. It has the provisions for side shift. Originally, this came with a double fork, and they took it off. So it has all the hoses and it has all the levers, but we want to put that on there as well. It'd be really nice to have the adjustable forks in and out, but that is more of a luxury to me. I'm used to sort of manhandling them, and I don't have a problem doing that. But we do need to replace the rear tires. I've had this out in the street. It doesn't get stuck, which is golden compared to the last one. But the tire in the back is looking a little rough. And when I was going over some curbs, they sort of chipped out. And we knew that would be coming. These tires are original. The front ones are wider and are under less abuse because they don't rotate. So we are just going to replace the back tires. And then we do have one hydraulic hose in here that is pretty dry rot cracked. And the tech said, hey, run it till it breaks. I don't know if I'll go that far, but basically they're multi-layered. And he told me that even though the outer sort of sheath is cracked, that you could probably still get several years of use out of it. So we want to do that. And then the most important thing to me is I'm going to be replacing these 42-inch forks with a 60-inch set. I don't want to go too long. 8 feet would be real nice. I want to still be able to maneuver in the shop nice and easy. But with the 42-inch forks, for what I do, it kind of doesn't work that well, to be honest. I unload and unload a lot of trailer equipment on trailers, and these 42-inch forks barely get halfway down a trailer. And for machinery rebuilding and moving stuff around, to be able to get out a little bit farther really makes a difference. And the nice thing about these is these are the thicker forks so that they can take 6,000 to 7,000 pounds. And the forks that I'm going to get are going to be rated for 8,600 pounds or 6,600 pounds and a 24-inch load center. So there'll be an upgrade in weight capacity and in length, so that'll be really nice. Other than that, mechanically, the forklift is in really, really good shape. And we're pretty much done with the repairs, and we're ready to just kind of put it to work. So if you guys enjoyed this video, let me know down below in the comments, and we will see you on the next one.